was a simple sphere, just 3.5 inches across, a polished ball of plutonium, warm to the touch. Originally slated for use against Japan had the war continued. It was the core for a third atomic bomb. It would never be used in war, but it would still claim its victims. History knows it as the Demon Core. At the Los Alamos laboratory after World War II, scientists continued to probe the limits of the atom. They performed dangerous criticality experiments, pushing the core to the very edge of a chain reaction, a process they called tickling the dragon's tail. On August 21, 1945, physicist Harry Daghlian was working alone at night. While stacking tungsten bricks around the core to reflect its neutrons, he dropped one. In that split second, the core went critical, unleashing a flash of blue light. As Daghlian instinctively knocked the brick away, his hand passed through the intense column of radiation. He had absorbed a fatal dose and died 25 days later in agony. The core, now scarred by one tragedy, was used again. 9 months later, the brilliant but notoriously bold physicist Louis Slotin demonstrated the same test. Known for his cavalier confidence, Slotin ignored safety protocols, using only a flathead screwdriver, his preferred and forbidden tool, to keep two halves of a beryllium sphere separated from the core. Then, the screwdriver slipped, the room erupted in an intense blue flash, a wave of heat and a sour taste of ionized air washed over the men. In a final, heroic act, Slotin used his body as a shield and tore the hemispheres apart with his bare hands, stopping the chain reaction. He knew instantly what he had done. He calmly turned to his colleagues and said, "Well, that does it." He died 9 days later, his body ravaged by radiation. The Demon Core had claimed its second victim. The hands-on, dragon-tickling era of nuclear physics was over, replaced forever by remote-controlled machines. The core itself, a cursed object that had killed 2 of its creators, was finally detonated in a nuclear test, or so they say. Its legacy is a brutal lesson, a terrifying monument to the human cost of discovery, and a permanent reminder that when you work with the fundamental powers of the universe, there is no room for error. Could we ever travel to another star? Not in science fiction, but in reality. Our nearest stellar neighbor, Proxima Centauri, beckons. It's the closest star to our sun, but close is a cosmic illusion. Proxima Centauri is over 4 light-years away, a staggering 25 trillion miles. Our fastest spacecraft, Voyager 1, would take 75,000 years to complete the journey. Chemical rockets, the technology that took us to the moon, are simply not powerful enough. To cross this ocean of space, we need a new kind of ship. For a robotic probe, our best bet is a laser sail. Imagine a massive, powerful laser array on Earth, firing a beam at a giant, ultra-thin sail in space. The pressure of the light itself would push the sail, accelerating a tiny nanocraft probe to 20% of the speed of light. A project called Breakthrough Starshot is working on this right now, aiming for a journey time of just over 20 years. But to send humans? That requires a far more powerful solution: a fusion rocket, a ship that harnesses the same energy that powers the stars themselves. A fusion drive could, in theory, get a human crew to Proxima Centauri in about 40 years. A voyage within a single lifetime. But even with such a ship, the challenges are immense. The crew would need to be shielded from deadly cosmic radiation. They would need a perfectly closed life support system to survive for decades. And they would face the profound consequences of time dilation. While 40 years would pass for them, even more time would have passed back on Earth. They would arrive at a new star, forever cut off from the world they left behind. So could we ever travel to Proxima Centauri? A robotic probe is almost a certainty within the next century. A human mission remains a multi-generational dream, perhaps the single greatest technological leap humanity will ever attempt. It is a journey that will test the limits of our science, our engineering, and our spirit. But it is a journey that a future version of humanity might just be brave enough to take.